Hello. So today we're going to talk about derivatives of trig functions. Give me a second to read the cartoon. Alright. So yesterday we did the derivative of sine of x by limits, and what I mean by limits is by the fundamental theorem of calculus. Today we're going to quickly review the derivative of cosine, then you're going to do a couple of others to finish up the 6 trig functions. So that's where we started. We have the definition of the derivative for sine of x. We then expand using the sum of angles for sine of x plus h. We collect terms. We bring this sine of x closer to this one so that we can collect the terms, so we can factor. And you can see that we split it up into the left and the right, where we're splitting our limit, and we have the sine of x and the sine of x. We then factor that. So we factor that right here. We know from yesterday that that goes to 0. It's another little formal way of doing it, and that's what we're showing right here, where we multiply through by the conjugate. Now this h will get canceled. Let's just take a quick look at the right side. We have sine of h over h. We know the limit of sine of h over h is always 1. So that's why this cosine comes in front. And that's why we're left with this cosine, because we know that this value right here is just a 1. Excellent. Alright, so the thing I want you to look at now is we have a negative sine squared h, cosine of h plus 1. And you can see that I've canceled the square, meaning I've taken out a sine, and I've taken out the h, because, because when we look at it, we know that the limit of sine of h over h as h approaches 0 is equal to 1. So we took that out of that, and that's what we were left with. Alright, but that doesn't matter. This is still going to go to 0. Cosine of h is 1. 1 plus 1 is 2. 0 divided by 2, still 0. So this whole thing goes to 0. And that's why we're left with just cosine of x. Alright, so when we do it with cosine, it's going to be very similar. Again, we have our sum of angles formula, this time for cosine. We're still going to collect terms. We have the cosine of x and cosine of x. That comes down. Take a minute. We're going to separate our limits. You're going to factor your cosine of x out. And again, this term is going to go to 0. This term is going to go to 1. So you have the negative sine of x still. We know this whole term, we discussed this yesterday, this whole term is going to go to 0. So again, on the right hand side we still have negative sine of x, negative sine of x. On our left hand side, this whole term, just like it was for the definition of sine of x, still going to go to 0. And again, we have that negative sine squared h cosine of h plus 1. So when we're done, we know the derivative of cosine is negative sine. So that gives us two important facts. The derivative of sine is cosine, the derivative of cosine is negative sine. You're going to use those so much, they'll just become, again, part of your memory. If you want to take the derivative of tan, I wouldn't expect you to do the definition of the derivative again. I would expect you to be using sine and cosine to do it. We know tan in terms of sine and cosine is sine over cosine. Good. So now you can use your quotient rule. We know the derivatives of sine and cosine, and you can finish that on your own. Pause the video, take a minute while you do that. Moving on to cotangent of x. Again, do not want you to use the definition of the derivative. Would rather you rewrite these in terms of sine and cosine. We know cotangent is cosine over sine, and we would want to take that derivative. Again, using the quotient rule. Pause the video while you finish that problem. Secant of x. Hopefully everybody remembers is 1 over cosine of x. And again, you'll use the quotient rule to finish that problem. Pause the video while you do that. Cosecant of x, we know is 1 over sine of x. Again, use the quotient rule to finish that. Pause the video while you do that. Okay, so here are our results. We knew the derivative of sine of x is cosine, the derivative of cosine is negative sine. And we then solve for the remaining 4. Great. See you tomorrow.